Hi, I'm Tim. Please join me in this video as I go through the Sig Antoinette kit, RC model airplane kit, build and fly. Let's get to it. I'm happy to report we have a new technical assistant on this video, Annie, our new neighbor dog from next door. Annie, can you say hi to viewers? Thank you. We're going to do an unboxing of the Sig 1909 Antoinette indoor scale RC model. But before we do that unboxing, I want to give you a little bit of background on Sig Aircraft Company and the Pioneers of Flight models that will be important for your background information. As always, thank you very much for any likes and subscribes you can do to this video. It truly helps with the channel and the YouTube algorithm. And if you need to know where you are in the video for the Antoinette, go ahead and just go to the timeline below and it'll show you what chapter we're on. Sig model aircraft were an absolutely iconic model airplane company in the US in the 80s and 90s. Any RC field you went to had Sig aircraft flying. They were wonderful sport flyers, scale flyers, just a top quality kit manufacturer from Montezuma, Iowa. They're still offering their kits on their website. It'll be in the description. And part of what they did for their offerings was the Pioneers of Flight. In the Pioneers of Flight, Sig produced 3 scale kits for indoor flyers of aircraft for the 1908-1909 time period. The 3 aircraft are the Demoiselle, the Depredussin, and the one we're going to build here is the Antoinette. I built the the Demoiselle back in 2008. Flew indoors. You can see it flew very well inside. Realistic slow flight. Just a wonderful model. Incredibly well engineered with a kit. Complete, but a very unique build experience with the supplied photo illustrated manual. You'll notice that the flight was very slow because we had to use at that time the kits were designed in 2002. They were designed for brushed geared electric motors and NiCad batteries. That was basically what people had. Sig was so concerned about the weight, they actually did not include a switch for the engine just to save a little bit of weight. Today, we don't have to worry about that. We're going to use lipos and brushless motors. The second kit I built was a Depredussin. You can see the takeoff here. The airplane crashed on takeoff. The video supplies a lot of information on that. I'll put the link in the description. And what I'm going to do to incorporate the lessons learned on this one is to not use the iron-on covering, and I'm not going to do any rigging till after the first test flight. I think that will help. So the kit I'm going to build next, we'll unbox here in just a moment, is the Antoinette. Remember, all 3 of the Pioneers of Flight, the Demoiselle, the Depredussin, the Antoinette, they were all French designs. The French were leaders in aircraft design at this time. The real measure of success was how powerful they could take the motors. The power of the motor determined everything. The Depredussin were very successful for the ones that were hand-built. There were no series productions. They were just, each one was a learning experience. But very attractive aircraft, very well recognized, and surprisingly modern in their layout with the tractor engines, the main wing, and the tail services to what we see flying today. So this is the box I ordered from Sig. It's not a heavy box. Go ahead and take off the cover. You can see there's not much in the kit. We've got this covering. We'll discuss that when we get to it. It's a special type of covering. We have to apply an adhesive, but it'd be lightweight. I think it'll work out okay. This is the entire wood pack. You can see there's not much here. A few parts with plywood. An incredibly detailed set of plans. You'll see that as we go through the building process. And what happened with this updated version, as I mentioned, it was originally designed in 2002. The parts are all laser cut. The wood is very high quality. The parts come out very well. The other key thing is there is an incredibly detailed, helpful, photo illustrated construction manual. You have plans. The parts are all cut out fine, but without The use of these step-by-step instructions, there is no way you can figure out how to build this airplane, but by using the instructions, it goes together in a very logical sequence. It's just such a unique model, you've got to have those instructions. So the takeaway is this kit is not for a beginning modeler, intermediate, or advanced modelers who will be able to put it together. And again, I'll take you step by step as we build the model. For the equipment to fly this plane, going to be very simple. It's a 3-channel model. The throttle with the electronic speed control, elevator, and rudder. There are no ailerons in this model, and that'll be that. I'm going to use the Park 370 motor, full description in the description, the same one I used on the Depard Dustin. We'll use the Castle Talon 25 electronic speed control, just a Spectrum 610, AR610 4-channel receiver, small servos, and I think I'm going to use these very lightweight wheels. They have kind of weird balsa wheels. You'd like to have spoked wheels. I don't have spoked wheels, so I'll use these for this model. That's all we really need, and a 2-cell lipo. So the next step is study the plans a bit, and we'll start building the fuselage, and I'll take you step by step through that. I always like to check the controls to make, or the radio to make sure it works. I have the Antoinette programmed in my DX6 Spectrum transmitter. Everything's powered up. You'll just take a quick look. The servos work okay, both the rudder and elevator. The electric motor, just to make sure that spins. It's good to make sure all that works before we start putting it in the aircraft. Here is the wood pile for the kit. There's really not that much there. It's just a lightweight kit, very good quality balsa, laser cut balsa, and that's it for the airplane. The plans are absolutely fantastic. They're just professional, well done plans. Everything you need is on here. Because of the unique construction methods of these early pioneers of flight by Sig, you simply have to have the photo illustrated manual to put them together. They share certain common characteristics like the wing construction, but you just got to follow that manual. There's no way to figure it out just looking at the plans itself. The wheels are kind of quirky, sort of spoke balsa wheels. I just used a regular airplane wheel for that. It's necessary to cut up the plans. I hate to do that, but to handle the plans, it's best to cut them up into smaller sections. There is a key to all the laser cut parts. They're not marked on the balsa parts themselves. And we'll go ahead and start with the fuselage. We just put out that fuselage plan. You have to measure some of the 1/8 inch square balsa to cut to the size of the fuselage, and tape measures handy for something like that. The fuselage is built upside down on the plans. This is the 1/8 inch square balsa that's put down first, again all per the instruction manual. After that we put in the cross members. Again, they're trying to keep the weight as low as possible on this aircraft. The next step is to build the fuselage formers. Again, each former is detailed on the plan. You can see underneath the grain, the direction of the balsa, and so forth. Continuing with the construction of the fuselage, the formers are put in place. That's the top pinned down to the building board. And we put in the bottom section of the fuselage, again, per the directions. Now I'm going to be putting in an outrunner engine on it, much bigger than the designed engine, so this is an initial look at what the nose is going to look like. More detail on that as we progress. I've started construction of the fuselage of the Antoinette. This is what I've done today. See, it's a fairly long fuselage, triangular, just to save weight, and you'll see this is a running commentary throughout the video. It's not strong construction because Sig was working in 2002 and the kit was designed to keep it as lightweight as possible for geared brushed motors and NiCad batteries. We can afford a little bit more weight because I'm going to put on an outrunner motor, and we're just going to have to make it a little bit stronger, and I'll go through that as we go along. What I did, for example, in the tail, I doubled up the 1/8 inch square balsa for the tail just to make it a little bit stronger there. But this is the fuselage so far here. One thing I want to point out is this is the motor I'm going to be using. Now, if you look on the side view of these wonderful plans, this is the original motor it was designed for. It is the geared electric motor, and it's a brushed motor. That's just, and it was a big prop that turned very slowly. They all use the same model. If I put my motor out here, it's going to look strange. So I'm going to put the motor a little bit further inside so it looks a little bit more normal. I'm not quite sure how I'm going to do that. This is what I've done so far, and you can see this is the original plywood firewall or beginning of the firewall, and I'll just have to build that up to make sure the motor can fit in there. But we'll discuss that as I build the model. The other thing I wanted to point out really quick, this is part of your design process. Notice the center of gravity is located here, which is fine. Notice how close the center of gravity is to the landing gear. If the landing gear was behind the center of gravity, it'd sit on its nose. We obviously don't want that. The landing gear is ever so slightly ahead of the center of gravity. That's going to be very tippy. I'm going to move the landing gear probably about a ½ inch forward just to make it a more positive sit on the tail when it's on the ground. So that's where we are so far with the fuselage. We'll continue building that and then go on with the rest of the airplane. What I've done here is I've put the motor onto a 1/8 inch plywood firewall cut out for the rear part of the motor. And we're going to put this in place and kind of just estimate and build around that as we do the fuselage. The motor is glued in now. You can see the ply reinforcing. And we'll just kind of build around this installation. The next step is the landing gear. Here's the plans for the landing gear. Nothing special about it, but a little bit weaker than I want. I'll keep the dowel for the main strut. It's a balsa dowel for the cross member. Here's a view of the plans and the plywood reinforcing where the vertical member meets the horizontal member. The side struts are put in and that'll be reinforced with thread. I then glued the landing gear into place with epoxy using plywood reinforcement to a plate on the fuselage and a side plate, and the wheels with the music wires just glued into that bottom member. Next up is the wing. This is the wing plan. It's a very simple wing. Balsa dowels for the front and rear leading edge. Those are the spars for the wings. These balsa dowels are used for lightweight. There's a slot cut in. You put 1/16 inch plywood to make it a little bit stronger for it plugs into the fuselage tubes. Here the front and rear balsa dowels are put into place. These are the spars for the wing. It's not as much strength as it needs. More about that later. As I mentioned, the parts are not marked on there, but there is a section in the plans that notes all the ribs. I just write that under the ribs. It is a tapered wing, so the ribs have to go into the right section, and that's what it looks like with the finished wing half. This is a good time to catch up with you on where we are with the Antoinette. So the fuselage is starting to come along. Per the directions, I should have some 1/32 inch balsa sheeting along here. I'm keeping this open because the model is designed to be as lightweight as humanly possible. For example, they don't even have an on-off switch. They just connect the NiCad battery in 2002 to the engine. So we're not doing that. We have a brushless motor in here. So I want to talk about how I'm adding strength as I go along. Is this going to be enough? I don't know. This is a work in progress. So this is plenty of power, a Park 250 motor up here. Because it's going to be fairly tight in the nose, I've installed the motor and I'm going to build the nose around this once I see where everything else goes inside the fuselage. I've also taken the opportunity to add some plywood reinforcing here, and to the firewall to have a stronger mounting for the engine. This is absolutely plenty for the engine, I believe, with this plywood here. The other thing that I beefed up significantly was the landing gear. The landing gear was extremely flimsy, but to be a lightweight model, this is a dowel, there's plywood reinforcing along here, and the wiring, and the plywood plates here to hold everything in place. For this light model, I think this will be sufficient. The ground run is going to be about 5 feet. It's just going to take off, and when it lands, it'll just kind of plunk down. We'll find out. So what will happen is I have done this portion of the fuselage so far. I have completed one wing, and I will add some reinforcements along here. Again, the wing is very light construction. These are literally balsa dowels, 1/4 inch rounded with plywood reinforcement here. There are tubes that will mount it here. So the next steps are to build the other wing, the tail surfaces, mount those on the fuselage. Then what I've got to do is to determine where the battery, the two-cell battery, is going to be located for the center of gravity with all that in place. Once I know somewhere along here the battery is going to be, I can put the mounting plate for that and then start thinking about covering, reinforcing, doing the rest of the model. So that's where we are for now. The tail surface is pretty easy to build. That'll be next on the agenda. Then I'll keep you updated as I make progress on that. Here, one wing half is plugged into the metal tubes. The tubes are glued into place on the tube mounts on the fuselage. Very important to get these right, both halves. This sets the incidence of the wing as well as the dihedral. Here is a view with both of the aluminum metal tubes in place, glued in place on the wing mounts. You can see them here in the front. In the back, the wing dowels just friction fit into these metal tube wing mounts. It's actually a pretty easy way to disassemble the wing for transport. Now we're going to start on the tail surfaces. Again, it's all covered in the instruction manual. It's really pretty simple, 1/8 inch square balsa. You just build directly over the plan with wax paper to keep them from being glued to the plans. Note a little bit of extra balsa for the control horns later installation. This will be a short update as we continue building the Antoinette of a stage that I'm at where I have to start thinking about the location of the battery pack to achieve the proper center of gravity. So if you take a look here, you will see that the tubes for the front portion of the wing and the back portion of the wing are glued into place. This provides the right incidence, dihedral, everything came out okay for that, and you can remove them for easier transport. I've started on the tails. You can see it's a very lightweight tail system that'll go on back there. Once I complete the horizontal and vertical tails, I'm going to simply tape them on the back. The center of gravity is located at former F5, which is right here. You can see right now the model is incredibly nose heavy because you have a motor up there. I'll put in the electronic speed control, have an idea where the servos go, but the battery is going to be the key determinant on the center of gravity. So right now, I have it about there. I'm getting in the regime of the proper center of gravity location. So I know that somewhere along here, I'll have to locate that battery to achieve the proper center of gravity. So I start thinking about that now because I'll have to build a top shelf on here to put the battery in that location, because that will be the one thing that I've got to get pretty close as I continue adding to the fuselage. Here is the vertical fin and rudders being built over the plan. Note a little bit of extra balsa here for the control horn, which will be installed later on. The landing gear is in place. You can see the motor is in place, and I've put in the electronic speed control and the initial location of the battery and the receiver, because I'll eventually cover this with one 32nd inch balsa, but everything is in place right now. We have another view of the wings glued in. Notice the control surfaces are taped in place. I'm doing the initial work of finding out where the center of gravity location is. This is determined by the heaviest component, the battery, to make it at the right center of gravity. Here's a side view of the battery on top. All the components are in place. And just to check that the servos do work, there's the elevator servo, the rudder servo, and the engine turns in the correct direction. Anna's going to help us with this look at the Antoinette. Are you ready, Annie? Thank you. You saw in the previous video that I put the wings and taped on the tail surfaces to the model to figure out the center of gravity location. Using a 2-cell battery, it turns out the battery will be about here for the proper center of gravity. It balances right at F4 right here. So that was good. Now that I know there's no interference for where the wing plugs in, the tail surface is, the servos will put in here. You can see the receiver is mounted on this little tray located here. Electronic speed control, connecting wires to the motor, exit for the battery connector, and these 1/16 inch balls on the top provides a good amount of strength for the model. It adds weight, but it also adds strength, so I'm happy there. And so now I can take balsa and form it onto the sides along here. All this will be enclosed inside. It's a supplied 132nd inch balsa. It's really thin balsa, but it's just to make it look good on the side. That'll go back here. Once that is in place, the fuselage is ready to be covered. We're going to be using the solar film that comes with the kit. It's an iron-on covering. It's a special one that doesn't shrink. It has to be applied with a thing called cover grip. Sig originally 20 years ago had a product called Sticks It, which was a kind of a sticky product you would brush on, and when you put the covering on there with heat, it would activate the glue to have it stick on. This is a replacement right here, and we will cover the model and then we'll be pretty much ready to fly. This is a little bit of a rough cut of the model. You'll see in the directions, the servos are very carefully mounted inside. There's thread that controls control surfaces. That's good. This one, I just want to see how it flies with this outrunner motor here, a little bit heavier weight. If you really like the way it looks, you can build a second one, to be my recommendation. But this is just the first iteration, a little bit heavier, a little bit stronger, to see how that works out for this model. Some of the 132nd inch balsa has been put on place on the side. It's a little bit curved, so that's helpful to make it look nice. And now it's time to start thinking about the covering. This is the covering that we're going to use. It's supplied on the kit. It is light span covering. You need to put an adhesive onto the balsa wood to have this adhere with the heat iron. I use cover grip that I got on Amazon, made by Deluxe Materials. It worked absolutely fine. The entire model is covered, or the outline is covered with the cover glue, and you have to let that dry. Then we'll put the covering on, activate it with a heat gun, and that's how it sticks to the balsa frame. So here's the wing. You can see that we covered just one side to make it lightweight, and you don't want it any tighter than this, just so you don't induce any warps into the structure. It's a very lightweight structure. We covered just the top surface of the stabilizer and elevator to save weight. Again, just with the iron, you heat activate that to go on. And for the fin and rudder, we cover both sides just because it looks better that way. Covering continues on the fuselage, the nose and the tail, just as before with the iron-on covering. Here the tail surfaces are being glued into place. I used epoxy glue for that. Make sure that you have sufficient room for the rudder and elevator, the fin glued in place. Note that the control horns are on the rudder and elevator at this time. I use Scotch tape for the hinges. It works fine for something like this. Very easy movement, and you can see with the cutout of the rudders, you can have the elevator going up and down with the rudder left and right. We've completed the Sig Antoinette airplane. This is it right here. So I just want to discuss some final things on it. We'll go ahead and power up the controls. You can see how everything works. I'll show how the wings are installed, talk a little bit about final notes of the construction. So as I've said throughout the video, this is an incredibly well-designed kit from Sig. The first came out in about 2002, and the plan's very well done. The instruction manual is perfect, but it was designed, built, and sold initially in an era where you had geared, brushed motors, very weak-powered motors that needed to be geared, swinging big props, and NiCad batteries for sure. So the plane was pretty much designed around that power system. The motors were very weak. The plane was designed to be as light as humanly possible. To show you the concern Sig had for that, they didn't even include an on-off switch and just connected the NiCad battery to the electronic speed control to power it up. Obviously, we're not going to do that today. I have a Park 250 brushless motor in it. It'll be plenty of power, but that adds a little bit more weight. And because the model was built for that NiCad powered brushed motor, it had to be kept as light as possible. I've made this model heavier and stronger with plywood to handle the increased power of the motor. The weight is 1 pound 5 ounce, which is higher than the standard one, but that's where we are. So we're going to see how it flies with all that. So why don't you give me a second to unplug the wings. As a matter of fact, I'll do that right now. The wings, per the instructions, I haven't changed that. They just pull out from these metal rods that are located right here. And you saw how I installed that. So those metal rods, these just friction fit in, and that's how the wings are installed. You can see to save weight, we just covered the top part of the wing with that light span covering with a stick-on glue, and that works fine. It's quite realistic how the real ones were. They weren't tight canvas, and that's what we've done to save weight. So these are the two wings removed. They just friction fit in, so that's that. Here is the fuselage. I thought as I was building this, I could put the battery here for the center of gravity. I was completely wrong on that. The battery has to go all the way up here, even with a few fishing lead weights to make the CG work. Next time somebody builds this, just locate all these servos much further forward. Again, with an intricate, kind of unique model like the Antoinette, I'd like to make a kind of rough initial cut just to see how things go together, see how it flies. If I like that, then I can make a second one, or this one, add all the control cables and things like that. We just have to see how this works. So the battery is installed. Let's look at the controls. What happens with these older antique flyers, you need absolute full control throw. So here is the elevator. You see it goes a lot, and then the rudder left and right. You're going to need that much to control these types of flyers. And the motor has plenty of power. So the wonderful brushless motors, that's how it'll work here with the battery just located on front to see how it flies. I think the landing gear is strong enough. I am going to take the advice of my wife for the initial flight, do a hand launch just to not worry about the takeoff. And then the next thing is to take it out to the field and fly it. And when I see you next, I'll be at the flying field. We're out here at the field for the test flight of the Antoinette. Here it is. It came out heavier than I expected, but we discussed that during the build process. One thing I did do is I added some racing wires to the bottom of the wings just in case they fold. I believe the weak point is where they're plugged in the fuselage, but we will find out during the test flight today. So the next step is connect the battery, flight control check, and then we'll take it for a test flight.
Good luck to you.
So do the control check, the motor, and notice the extreme control throws you need it for these slow flying antique airplanes. So the elevator should be up, down, and rudder left, right, and then the throttle looks okay. So now we will give it a test flight. So here we are on the actual maiden flight of the Antoinette, plenty of power. I give it a hand launch, and then it starts pulling to the right. I can't turn left. This is just what happened on the Deborah Dozen. I noticed the wings were flexing a fair amount just due to the heavy weight of the model and the speed. I was a little bit faster than maybe I should have been. For whatever reason, I just decided to reduce power to slow down the model. Once it slowed down, the wings stopped their flexing and the Antoinette flew just fine. You can see that it's very stable. I kept it in the left turns because that was working well for me. When it turned, it almost pivoted, but it just is a very comfortable model flying at this slower airspeed. Now it's time to line up for a final approach and a landing, just totally under control, not much wind, elevator working all the way down, and actually a pretty good touchdown for a maiden flight. Well, we just finished the test flight of the Antoinette. I'm very happy that it flew, but I'm just going to be straight up with you. I was working full time on the 6 to figure out how this thing works. The model's a good model. I've no problem with the kit, but it's essentially a free flight model that Sig made a little bit stronger for a very lightweight electric motor, lightweight. I could see with the weight of this brushless motor and just all the structure that I put in to make it stronger, the wings were flexing as it was flying along. And so with the wings flex like that, it's a very inconsistent lift pattern for the model. And so I realized that at first it just wasn't turning left, but when I slowed down and there was less movement on the wing flexing, I could do it as left-hand turns the whole time. I just didn't want to experiment with the right-hand turn. But at a lower airspeed, a lower throttle setting, it maintained pretty good control. The rudders are small, they're not big rudders. You like bigger rudders. The elevator was fine. And then you saw on the landing when it slowed down, it actually landed pretty good. So I'm happy that it flew. If you build one yourself, you're going to have to do something to make the wings stronger. What I recommend for stronger wings, and I've thought about this, is you'll see here they use balsa dowels for the wing leading and trailing edge. These are lightweight, not much strength because it's supposed to be very light, with the 1/16 inch ply inserts in here. What I would do is, this section out to about here, I would make a aluminum metal tube, and then either the balsa dowel or real dowel, plug that into the metal tube for the remainder of the wing, and that way when you have the metal tube into this metal tube here, that should provide a little bit better strength for the wing. But it's a very interesting build. I'm glad I did it. It's a beautiful kit, and we got a flight out of it.